All right, let's see if this works. A group sets out on a bearing 240 degrees true from the hut. They walk at 4 kilometers per hour. At the same time, a group leaves the same hut on a bearing of 030 degrees true at 5 kilometers per hour. You have to say when you speak them, you have to speak each number separately, like 240 degrees and 030 degrees true. They both travel for 3 hours. What A is diagram, B is distance apart, and let's see if this works. Let's see if I can make that bigger. Let's get a diagram. Can I change the colour? Doesn't matter. Let's leave it as blue. So there's a hut. Let's put the hut in the middle. And let's get the first group, 240, well, that's west. And that's south. And then you've got like a clock, 6 o'clock, 7 o'clock, 8 o'clock. Now every 30 degrees, that's 210, 240. So what we have is a group sitting out this way for 3 hours, at 4 kilometers per hour. So speed equals distance over time. Distance equals speed times time. Speed is 4 kilometers per hour. Time is 3 hours. So you've got, if I just do that again, 4 kilometers per hour, 3 hours. You see the hours cross out. Oh, that's not a very good colour. Then you've got 12 kilometers. 12 kilometers, so a distance of 12. And the second group, leave it a bearing of 030. Well, north, 000, east, 090. So you got this clock, 2 o'clock, 1 o'clock, 2 o'clock. So the 1 o'clock position is 030, and distance there, speed is 5 kilometers per hour, 3 hours. So the hours cancel, 15 kilometers. So we're going to have slightly longer. So if that's like 4, then we got 4, 8, 12, 16, all right, about there. So they'll finish up about there, finishing there, okay. The distance apart after 3 hours. Okay, well, this is not easy. We want that distance there. Okay, so, well, we could break it up into 2 triangles. Like this. We don't have to, but we could. And this angle here, let's see, well, you know what, I'm going to do something different. Can I back arrow? Can I make 2 triangles like this? Can I make that triangle? Can I change the color? I wish I could change the color. Oh yeah, I can. Then I want to maybe make that triangle, that green triangle. And really, I'm going to make two triangles here. Now, this is 60 degrees here. That's 30. This is 60. That's 30. So that's 12. That's 15. All right, so let's go across the X, the red here. This distance here. So we're going to have, this is 12 cos 30. Because you've got, can I make that triangle a bit bigger? How do we get rid of that? All right. So we've got this little 12, an X, a Y, 30. So cos 30 equals adjacent over hypotenuse. So 12 times cos 30 is equal to that X. Yep. And the Y, which is that Y there, is sine 30 because opposite over hypotenuse. So the Y value is 12 sine 30. And I'm not sure if you're familiar with sine 30 equals a half, and cos 30 is root 3 over 2 from the triangle, which is like, if you take an equilateral triangle, 2, 2, 2, split it up into 1, 2, that would be root 3 because of 1 squared plus root 3 squared equals 2 squared. And then that would be 60, that would be 30. So sine of 30 equals opposite over hypotenuse, which is 1 over 2. And from the 60 degree, from the cos of 30 is adjacent over hypotenuse, which is root 3 over 2. So you could change cos of 30 into root 3 over 2. Can I get rid of that triangle? Yeah. So 12 times cos of 30 is root 3 over 2. So that's 6 root 3. So 6 root 3 is this one. And 12 times a half is 6. So that's 6 there. And then we go up to this triangle. We've got a 60. We want this X and this Y. And the hypotenuse is 15. So cos of 60 equals adjacent over hypotenuse. So 15 times cos of 60 equals X. And here cos of 60 is adjacent over hypotenuse. Cos of 60 is a half. And so we can go 15 times half equals X, and that's 7.5. So that's 7.5. And then the Y value is sine of 60 is opposite over hypotenuse. Sine of 60 equals, so 15 times sine of 60. Sine of 60 is from this triangle, opposite over hypotenuse, root 3 over 2. So it's 15 times root 3 over 2. That's just 15 root 3 over 2. So I'll leave that as 15 root 3 over 2. It's not, oh. Now, we've got one big triangle, and I want the hypotenuse. So the big triangle has, can I scroll that up? Will it go down any further? Or is that as far as we can go? That's as far as it can go. So this triangle has 6 root 3 plus 7.5. 6.3, 6.6 root 3 plus 7.5. That's the length here. And then this height is going to be 6 plus 15 root 3 over 2. I wonder if I can make this go further. I'll go up here. So I've got this triangle. What happened? Did I go over it? Okay, but anyway, it was 6, if I can remember correctly, it was 6 root 3 plus 7.5. This was 6 plus 15 root 3 over 2, because we had these two triangles. But we want to make that one big triangle. So if I 6 plus 15 root 3 over 2, therefore that distance squared equals 6 root 3 plus 7.5 squared plus 6 plus 15 root 3 over 2 squared. Okay, that's as far as I can go. I would, it'd be crazy if you need to go any further than that just for a question like this. And if it's a non-calculator, the angle, well, the distance, we'd have to know, we'd have to sort of know this angle here, the bearing of the second group up here from the first group. So we'd have to know this angle here and take it off 90 degrees because that's 090. And we get that angle by doing opposite. I'll just call that tan of alpha equals opposite, which was 15 root 3 over 2 plus 6 over adjacent, which was 6 root 3 plus 7.5. So whatever that fraction is, you then get the angle by getting the inverse tan of that answer. And whatever that is, you take that angle off 90 and that would be the bearing. So if that was, say, 15 degrees, which it's not, you'd go 90 take 15 is 75, so the angle would be 0.75 degrees true. Horrible question.